Today I'm going to go over Unit 4B review. I'm going to do a select few problems. I'm not going to do all of them, but I will do the ones I believe will be the most important for the test. So number one here, I'm able to find the amplitude, period, phase shift, and vertical shift based off of our A, B, C, and D values. All right. Amplitude is going to be always our A value. Our period is going to be 2 pi divided by our B value, so that's going to be the only one we can't pull straight out of the equation. Our phase shift will be C, and our vertical shift will be D. Alright, so if you'd like to take a minute and try number 2 on your own, go ahead. I'll pause the video there. Alright, those are the answers for number 2. I'm going to move on to question number 3 here, which is graphing the equation we have from number 2. So how we're going to do this is we're going to start with our midline, which we said was 4. So that's the same as the vertical shift. So I'm going to dash in a line at 4. Right? And from there I can take the amplitude, and we said the amplitude was 2, so I can go both up 2 and down 2 from the middle line. So up to 6 and down to 2. Those will be my maximum and minimum values for this graph. Next, I can plot my starting point with my phase shift. So this is a negative sine graph, so it's going to start in the middle and go down first. And we said our phase shift was pi over 4. So that's going to be at the middle, the midline, and x equals pi over 4. So right there, the blue point. And then from there I can go over by my period, which is 4 pi, we said. So this dark purple point will be that. So if I go over 4 pi to the right from there, that's going to be right here between 4 pi and 9 pi over 2. So that's where my cycle is going to end. And then I can plot the 3 middle points, keeping in mind that this graph goes down first from the start. And these 3 points will be evenly spaced. So right halfway between these 2 points will be another middle point, which will be right here. Right? Halfway between the blue one and the light green one will be our minimum value, which will be down here. And our maximum past on the right side between the middle green point and the purple point will be up here. Alright, my points were slightly off, so I paused and adjusted them, but they were off by about half a line, so it wasn't too far off. And then the last thing we want to do is make sure we show as many cycles as possible, so we're going to extend this pattern as far as it goes. Right? So I'm going to put a point here, one right about there, and it's going to be right about there. So I do want to continue this pattern as much as I can fit into the graph. Right, and that's what our graph is going to look like, roughly. It does repeat forever, but yeah. I'm going to move on to question number 5 on the next page. All right, so this is the process of taking a graph and creating an equation, or I guess creating an equation from it, but we're getting the A, B, C, and D values. So we can find our A value by looking at our maximum and our minimum and finding half the distance between those. So distance between the 2 points is going to be subtraction, so 11 minus 3. 11 is our maximum, 3 is our minimum, and we want to find half that distance. So that's going to be 8 over 2, which equals 4. Right? Our B value will be it will be 2 pi divided by the length of 1 period. So our period is 1 wavelength, so the distance from -3 to 5, or top to top of the graph, is 8 units, so 2 pi over 8, which equals pi over 4. Right? And then our c value is our phase shift. So since we're looking at a cosine graph, I'm going to look at the top. There are multiple correct answers for c. You can do the phase shift left, or you can do the phase shift right, because this does repeat, so there are multiple answers. So the two I'm going to give, since I used a positive a value, I'm looking at the start of the graph is at the top, because this is cosine. So there's two possible answers. Could be c could be -3 or +5. Right? So the top is at -3, 11, and +5, 11. So either one of those would work. And then our d value is our midline. Sometimes you can just see it on the graph, which is cool. That works. You can also find the average of the maximum and minimum. So 11 is our max plus our minimum divided by 2, which is going to be 14 divided by 2, which is 7. Right? Right, I'm going to move on to question number 7. This is basically just a multiple choice. Which graph is this? So we just want to think about what we know about the shapes of these graphs. Cotangent looks like a tangent flipped over. It kind of looks like a negative tangent graph, which is some downward lines like this. Right, so we can clearly see this is not going to be cotangent at all. So it leaves us with not D. Cosecant and secant both touch, so they're both flipped, like they're both the reciprocals of sine and cosine. So they're going to be very related to sine and cosine, right? In fact, they're going to touch like all the tops, the maxes and minimums of cosine and sine, so there's going to be a nice wave between these two, nice and easy between like that. What this means is that our maximum, we have a high point right here at x equals 0, so that means our graph is starting at a maximum. So this is going to be related to cosine, and since cosecant is the reciprocal of sine, it's not going to be a cosecant. And since a normal sine graph will start at +1, this graph looks like it starts at y equals 1/2, so it's half of a sine, so that's where we're getting B as an answer. So we're just going to use what we know of graphs for this kind of a problem. But I'm going to move on to question number 10. A question like this will show up on the test. I believe you should be able to do this out of calculator. We're going to use what we know from the unit circle to do this, right? Keeping in mind the domains of each function. So the domain of cosine inverse and sine inverse is between -1 and 1. And since -2 is not between those two, we can't actually get a result for cosine inverse of -2. So this is going to be undefined. Right? Sine inverse of square root of 3 over 2. We're basically asking ourselves, sine of what angle gives us the square root of 3 divided by 2? Using our knowledge of the unit circle, we will be able to know that that is, in fact, pi over 3. Right, similarly, for tangent inverse of 1, we're asking what angle gives us the tangent of, or what tangent of what angle gives us 1? That angle is pi over 4. Right, in D, we're asking cosine of what angle gives us -1/2. Right? So cosine inverse has a range of quadrants 1 and quadrant 2. Right? So this is either going to be in quadrant 1 or quadrant 2. Since this is negative, we know from last unit that cosine will be negative in quadrant 2. So this angle has to be in quadrant 2 somewhere. Right? And that's going to be the angle closest to vertical, which is 2 pi over 3 from our unit circle. Right? I'm going to move on to question number 11. We're going to talk about that one really fast, both aspects of it. So part A, we're going to see sometimes that this sine and sine inverse are going to cancel each other out, right? So this is just going to equal the square root of 3 over 2. Right? One thing we do have to be careful about in a situation like this is that our angle doesn't change quadrants. It is possible that that can happen, and it usually happens when it involves an angle that doesn't show up in the range of the function we're using. But yeah, so part B is going to be slightly different. 4/5 does not show up in our unit circle, so what we can do instead is draw a picture. So we just want to think about this right here. So on the inside here it says cosine inverse is 4/5, which means that cosine of some angle is 4 over 5. We want to figure out what quadrant that's in. So keep in mind that the range of cosine is the first and second quadrants. So it's not going to be quadrant 3 or quadrant 4. It also has a cosine that is a positive number. So that happens only in quadrant 1. So we can also cross out quadrant 2. So it's going to be in quadrant 1. So our angle is going to be something like this. That'll make a nice right triangle. And remember, cosine is adjacent over hypotenuse. So our adjacent side is here. Our hypotenuse is here. If we want to find the missing side now, so we can actually do the tangent of our angle, which is there, we can use Pythagorean theorem, which is a squared plus b squared equals c squared, and we'll get that our missing side length is 3. So that means tangent of that will be equal to opposite over adjacent, so 3 over 4. So we'll get 3/4 here. Right? And then lastly we have question 12. Just like the last one, make sure a good starting process is to draw a picture. So we're going to have a building that's 500 feet tall, right? 500 feet. And we're standing 75 feet away at some point over here. And these make a nice right triangle. We're trying to find the angle of elevation, so that's this angle down here, the angle going upwards. So we know that the tangent of this angle, because we have the opposite side and the hypotenuse, is going to be 500 over 75. So how we undo tangent, how we solve this for theta, is we just do tangent inverse of both sides. So theta has to equal tangent inverse of 500 divided by 75. So when you put this in a calculator, make sure you're in degrees mode if you want an answer in degrees, or radians mode if you want an answer in radians. So theta will equal about 81.5 degrees. And I think that was close to 1.5 radians. It was 1.4 or 1.5. I'm not sure off the top of my head, but it was. Anything I did not cover, please feel free to try on your own. Make sure you think about which quadrants go where, ranges and domains of all of our functions, and stuff like that. Yeah.